Section 4.1, Exponential Functions, Part 5. Famous exponential functions are interest equations. There's two interest equations that we're going to be looking at. One is compound interest. That's the formula that you see here. Another interest formula that we'll look at next is continuous interest. We either have compound interest or continuous interest. Compound interest has an n in its formula, and that's going to be how we determine that this formula is what we're going to use if they give us some key wording in the problem that is going to hint at an n value. What is an n value? N is the number of times per year that we add interest into our account. So in our problem, should they say the interest is compounded annually, we know we have an n, and n is 1. If the problem says interest is compounded monthly, then we know we have an n, and n is going to be 12. So for n, or compound interest, try to look for these keywords: compounded annually, compounded daily, compounded quarterly. That's what's going to determine that compound interest, this formula that you see here, is what we're going to need. Okay, so P is your principal. That's going to be your initial investment. R is your interest rate. We're going to always turn our interest rate from percent into decimal in order to get a correct calculation. N, just like we explained, is how many times we're going to put in interest into our account for the year. Daily, weekly, quarterly, the problem will give us that information. Then we have time. Time is always going to be in years. Okay, so let's look at our first example. For our first example, we have, if $2,500 is invested at an interest rate of 2.5% per year, compounded daily, find the value of the investment after the given number of years. Okay, so let's see what we have in our problem information. We have $2,500 invested. That's our initial amount, and so that's going to be the principal. We have an interest rate of 2.5%, so that's going to be R. Remember to always turn R into a decimal before you use it in your formula. Then we have compounded daily. This is where N appears. Compounded daily is our key wording that we're going to have this formula that involves N. Compounded daily, N is going to be 365. Okay, after a given number of years, that's going to be our T. Okay, so we have A equals P 1 plus R over N raised to the NT. Okay, so we want to know how much money, that's the amount, in our account if we invest an initial amount of $2,500. Our interest rate, 2.5%. We always be sure to turn that into a decimal. Compounded daily, so that's going to be 365. 365 to how many years? 2 for problem number A. Okay, so let's get that put into our calculator. Okay, so we're going to have 2,500 times 1 plus 0.025 divided by 365. That's going to be raised to the 365 times 2 power. Important parentheses here. I need a complete set of parentheses for my power. I need a complete set of parentheses for what I'm raising to that power. Okay, we hit enter, and what we see is we're going to have, after 2 years, $2,628.17. Okay, so after 2 years, we're going to have $2,628.17. Okay, next one, part B. Time is, instead of 2 years, how much are we going to have into our account after 3 years? Okay, so the only thing that changes is that becomes a 3. Okay, so we're going to hit the second button. Then we're going to hit enter, which is in the lower right corner. That brings up our formula that we just typed. You can do second enter a few times, and it'll go back a number of lines into the history of your calculations. Okay, so we're going to hit the back arrow. Instead of 2 years, we're going to make that 3 years. And if we make that 3 years, we have $2,694.70. So after 2 years, about $2,600. After 3 years, $2,794.70. Okay, one more. 6 years. Okay, so we're just going to change that to a 6. And now we have our calculation. We're going to hit second enter. Instead of 3 years, now we have 6 years. And we end up with $2,904.57. So account is up to, after 6 years, $2,904.57. Okay, so let's go to the next example, and then we're done. Okay, so the present value is a sum of money that must be invested now. Okay, so present value, how much must we invest now? Okay, so that's what we're finding is the present value. We want to find P. How much must we invest now in order to have our account accumulate to $100,000? If our interest rate is 8% per year, here's our key wording. This is how I know I'm using this formula with N, because it says compounded monthly. So I'm going to use the formula with an N in it. For 5 years, that would be our time. Okay, so we have A equals P1 plus R over N raised to the NT. Okay, so we want an amount of $100,000. We want to know how much do we have to invest now in order for it to be that amount after 5 years. So then we have our interest rate. Again, very important. Make sure you put your interest rate in decimal. For compounded monthly, we're going to put in interest every month. So N is equal to 12 for 5 years. Okay, so we're solving for P. Okay, so let's go ahead and get all of this calculated inside of the parentheses. 12 times 5 is 60. So I'm going to go ahead and just write that for the decimal point. Okay, so we're going to take 1 plus 0.08 divided by 12. That gives us 1.0067. Let's call it that. 1.0067. Okay, so next we're going to take that and raise that to the 60th power. Okay, so if we raise that to the 60th power, that gives us 1 point 1.4898. So then to solve for P, all we need to do is divide this over. So we're going to take 100,000. We're going to divide over 1.4898. And we want to not round too early. I'm not actually using just 4 decimals in my calculation. I'm going to use all the decimals available in our calculator. Okay, so I'm going to hit second arrow, enter. Okay, so, maybe it's just easy to type this in. Sorry about this. Okay, 1 plus 0.08 divided by 12. Okay, so that gave us the inside of our parentheses. We raised that to the 60th power. That gave us our 1.4898. Now I'm going to take 100,000 and divide that by the last answer displayed. So I'm going to hit second and ANS. That's like a holding cell that the last answer displayed gets put into there. We hit enter. And so in order to have $100,000 at 8% for 5 years, compounding monthly, today we would have to deposit $67,121.04. Okay, that finishes section 4.1 notes. What you should do now is log on to WebAssign and work on the section 4.1 homework.